Hey,
Hey, we're live.
we are.
I was just watching the video and it was fun.
Oh, okay. Hey, look at that, we're live. Paul says,
Yeah,
"Hey, we've
yeah,
been doing this all along."
With three wild and crazy guys.
waka waka waka.
Good evening, everybody. Welcome back. Okay, and welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show.
Yay!
Hey, there, that's better. That's better. You're getting better. It's taken about a year, but we got there.
Well, nobody's holding the applause sign up, so
Yeah, that's true. Yeah.
Well, that's
we,
what
well,
that's
we were doing
for.
it before the picture was up. Yeah. The Brampton Observatory. Love your new graphic. Thanks very much. Hey, Paul from UK, and Chris is on here from Northern California. Welcome, everybody. And
hey,
everybody's on
hello.
Facebook. Nice big crowd tonight. Hey.
That's terrific.
All right. My name is Chris Kerwin of Astronomy by the Bay. I'm a member of the Royal Astronomical Society of Canada, the New Brunswick chapter, and located here in St. John. First of all, I'd like to welcome back our two regular co-hosts from the beautiful Moonshadow Observatory in Hampton, New Brunswick, Mr. Paul Owen, RAS member, fellow RAS member. Hey! And fellow RAS member Mike Powell from the PFO Observatory here in St. John. Hey, Mike.
Oh.
Yeah.
Silent F.
All right, give me one of them nights. Good thing I got my big cup of coffee. Yeah. And a special salute as well tonight to my little brother Danny, who tunes into us every week. Hey, Dan.
Hey Dan, how's it going?
Dan.
He always waits. He always waits for her little high. So now on tonight's episode, yeah. On tonight's episode of the Sunday Night Astronomy Show. Okay, so you're standing under the night sky with binoculars in hand or with the telescope all set to observe. Now what? There we go. Bishop.
Clouds roll in.
That's usually the way. Bishop Desmond Tutu of South Africa once said, "There's only one way to eat an elephant, a bite at a time." And that's the approach we need to take when we're learning the night sky. And there are many tools to help us. One way is a technique known as starhopping, something we'll talk a little bit about this week. Also this week, got cloudy skies, got milk. How about radio astronomy? On Mike's Gearbox segment, he'll discuss his itty-bitty radio telescope, one of his top Mike Guyver projects. Yes, sir. Looking forward to that. Also, there's much more to capturing images than just collecting data. Paul is going to reveal the many software requirements you need before you ever capture a photon. Yes, sir. And we'll have our regular editions as well, including Rosanna's Fun Facts episode, the Bino Buds Target of the Week. Don't know which one it is yet, but we'll learn, I guess, all at the same time. There we go. Uh-oh. And if we get time, we'll take a look at what's up in the night sky this week. We've also got a pile of photo submissions here that we want to show off, your photos. So truly an astronomy variety show this week. So sit back and grab your favorite beverage or snack and enjoy. And remember, this is a family-friendly live broadcast. Maybe you've already have your snacks watching the Super Bowl. I don't know what time that starts tonight. I don't even know.
Doesn't matter.
Doesn't matter. Yeah. We're not breaking for the halftime show. So,
no.
We're happy to try to answer any of your questions here. So let's get started with tonight's program.
All right.
Okay. So who's tuned in for Super Bowl? Looks like we got a pretty good crowd here, I'd say. So I think we're doing okay.
Excellent. We got their attention.
We don't really care. Yeah. Good evening from St. Margaret's. Hey, Caroline. Okay, let's go down through some. I guess we're going to start off with Mike's talk on his IBRT, itty bitty radio telescope.
That's what it is.
So take it away, Mike.
Entire screen. Share. We should be up and running. We look good?
It looks great.
Awesome.
All look good. And I want to say hello to Claire from Scotland joining us tonight as well. Hey, Claire.
Hi,
Thank you.
Claire.
Hello.
All right. This is Astronomy with MacGyver. And tonight I'm going to talk to you about something. When we go to star parties, I was actually thinking about buying myself a dedicated solar scope. But then I thought, every time we go out to a star party or we get a large gathering, there's always one around. And, you know, it's a fairly big expense to buy just a dedicated solar scope. But every time we have a star party, there's lots of them. And there's all kinds of white light filters and stuff like that are set up. So I wanted to know, what can I do that's different? What can I do to draw the crowd in? And I came across something that was called Build Yourself an Itty Bitty Radio Telescope. And I thought, now you're talking my language. This is pretty cool. How do I do that? Well, the first thing you do is you find yourself an old satellite dish. And trust me, there's a ton of them out there. You can go on Marketplace or Kijiji and people are giving them away. So it's not difficult to find yourself an old satellite dish, and any satellite dish will do. So get yourself an old satellite dish. Then there's something on the front called an LMB, which is a low noise block converter. Now, most of them have at least one plug-in. More commonly is two, but you can get them up to 5 and 6 different plug-ins. I suggest you get yourself one that has at least 2 plugs on it, and I'll show you why after. One is to connect to your detector, and that's what we're going to show you how to do. And then the second one, I'll show you an option that you can add to it. Also, you're going to need yourself a whole bunch of paint because you don't want it to look like everybody else's. You don't want to say Bell or Fundy on it. So you paint it all up, any colors you like, and get yourself some stickers and have some fun that way. Use your artistic talent. You're going to need some coaxial cable, which is, everybody's got coax laying around. If not, the dollar store and Value Village has all kinds of it that practically give away. So get yourself some coaxial cable. And then you can go on Amazon or eBay or something like that, or even look around in these places like the Sally Ann and whatnot, and you might find yourself an actual satellite detector. If not, you can purchase one. They range anywhere from $10 to $60, depending on how complicated one you want. But basically, it's just a needle that moves, or it's a graph that moves to tell you how strong your signal strength is. You're going to need one of those. And you need an 18-volt power source, which is real easy to make using 2 9-volt batteries, a little bit of wire, a couple of connectors, and a coaxial cable. It's pretty simple. And I'll show you how you do that after. So the simple build, you make your 18-volt power supply, you connect it to the satellite detector, then you connect the satellite detector to the satellite dish, and you point it at the sun, because that's what I built it for, was to listen to the sun, which is actually pretty cool. And guess what? It does work. How do you wire up the battery pack? Pretty simple. You got 2 9-volt batteries that are going to sit in what's called series, not parallel. So you don't connect positive to positive. You actually connect positive to negative, negative to positive, around, positive back to negative, and negative back to positive. And then you hook your negative cable to the ground on your coaxial cable, hook the positive to the center wire on your coaxial cable, and now you have yourself an 18-volt power source. It's real simple. Anybody that wants this picture afterwards, let me know. We can post it somehow. But it's a real easy wiring diagram. Red is positive and black is negative. So you connect the battery that you put together, your 18 volts, to the satellite finder, and it connects to the receiver end. So you're not going to connect a regular satellite receiver. That's where your power source is going to come in, because that's how it's actually done. When you buy a satellite receiver, when you're using satellite dishes, it supplies the 18 volts to the satellite finder. So that's the end you plug into. The receiver end is where you plug in your battery pack. And then the other end, you connect directly to the LNB, or that piece that goes on the very end of your satellite dish. That's where it plugs in. It plugs into the satellite on this end. And you're off to the races. Now, what I did on mine is I wanted to be able to have it track the sun. So in the long arm that holds the LNB, all I did was drill 2 1/4-inch holes in it, and I bolted a Vixen rail to the bottom. And now I can mount it on an equatorial mount, and it will track the sun all day long, and I don't have to move it and move it and move it. So it'll track the sun all day long. And it was just a simple, take the wires out, drill the 2 holes, bolt it together, and shove your wires back in, and you're off to the races. Now you get yourself a mount for your satellite dish. And you mount it on an equatorial mount, and you're ready to go. And that's what it looks like. There's your satellite dish, a little bit paint, throw it together, make it look good, and your wires are connected, and away you go. Now, point this dish at the sun, and what happens? Well, when you point the dish at the sun, you're going to watch for a change in the satellite finder, and you can see the VU meter go back and forth. The needle will move. Now, it might, when you get it dead on the sun, it might go over and pin itself to the +3 side or +8 or whatever it is. But you usually have a knob on it or an adjuster that you can adjust that down a bit. And you want to adjust it so it sits on 0. And after that, you can just watch the needle. And if there's solar flares and whatnot, you will actually see that needle move because of the solar flares. And it's really, really cool. And that's basically how you set up your satellite dish to become an itty-bitty radio telescope to look at the sun. Now, me being me, I have to go one step further. And this is where that other plug-in on the dongle or on the satellite dish comes in. You add what's called an SDR, or a software-defined radio dongle, to the second LNB connection. You modify the coaxial cable, which is real simple to do, in order to plug that coaxial onto the antenna portion of the dongle. And I'll show you a picture of that. Connect the Sdr dongle to your laptop or PC, whatever you're using. You run some free software-defined radio software, and it's absolutely free. And then you're going to watch the waterfall that comes down and watch the changes in the waterfall. So these are the SDR dongles that you can get. This one plugs directly into a USB port. And this one here, you basically plug a USB cable into it and plug it into your laptop. And they run anywhere from, say, $30 to $300, depending on what you want. But the $30 one works just as well for what we're doing here at the Itty Bitty Radio Telescope. And then you get some software-defined radio software. And this is what it gives you. It gives you a graph of what's going on, and it gives you a waterfall. And this blue piece on the top is like a waterfall. It slowly moves down the screen. And as there's activity on the sun, you can see a couple of lines here where it's faded, but it pushes out. That's activity on the sun. And you're watching it in real time. So it's pretty cool. Here's the example of the connection. Basically, you come off the satellite dish, and it comes in and it plugs into your satellite finder, which I had, which plugs into the 18-volt battery. And you can watch the needle move back and forth. And then the second one that you plugged into the satellite dish comes around, plugs into this SDR dongle, plugs into your laptop. You pull up the waterfall software, and guess what? You're looking at the sun on your laptop, and it's the coolest thing. And this is what you're going to see, basically. This is the sun at 39.6 megahertz with an SDR dongle. And basically, you can see here, it's across the radio spectrum, and you can see where it's light, that's the sun. So every time there's a different, say, magnetic pulse or something on the sun, you will pick it up. You'll see it turn slowly white on the screen, and it's really cool. It's not just static. There's something going on behind that static, and it's just another cool thing. So when everybody else is looking at the sun through these solar scopes and are looking at it with a white light filter, you can come over to a laptop and watch exactly what's going on at the same time, and it's just another way to interpret that information, and it's really, really cool. And I know it works because I've been there and done that. This is when we were at Livingston Lake. I set up with it. And guess what? It works really well. I was so impressed that I could actually watch the sun on my laptop via radio software. So it's a really, really cool thing to get into. Simple build. Anybody wants to know, get a hold of me and I'll tell you exactly how to do it. Or you can just go to Google and type in, how do I build an itty bitty radio telescope? And it tells you exactly how to do it. There's about 15 different places out there. So anyway.
Only you, Mike. Only you.
If you want to, well, it's something that's different. That you walk out to a field full of telescopes and everybody's standing around, and then they see this satellite, just and go, "What's going on?" The crowd comes over.
Yeah, they
So
do.
it's a crowd catcher.
Yeah.
Anyway, that's the basic short of it on how to build an itty bitty radio telescope. So,
Awesome.
and I'll stop sharing. And just to show you quickly, there it is right behind me on an equatorial mount. It's got a little 9-volt bullet battery drive on it to turn with the sky, and I can listen to the sun all day long.
Yeah, I remember the first time you set that up, I said, okay, what's he up to now? And everybody else looking at the sun with solar scopes, and Mike's over there with a dish, tuning in the TV channel.
If you look at all the radio stuff behind them, you can see
Gotta be different.
the radio.
Yeah. No question. Thanks, Mike. Great talk. We're looking forward to getting that thing out again this summer with our Star Party events. Let's hope they come back. Yeah, we're really anxious for those for sure. Okay, I'll do a real quick talk then on one of my main topics, I guess, would be star hopping. So try to get through this as quickly as possible because Paul's got a nice talk here in software as well, so we want to get to that. So let me see what I can get up here. Looks like we're up on screen. Waiting for feed showing it. I see it up on YouTube.
We're on Facebook.
Awesome. Okay, so star hopping. What's it all about? Well, you step outside on a clear night, you look towards the south, this is what you see. You stare back with determination to learn about what you are viewing, and then all of a sudden you become overwhelmed. Well, it just takes some practice. Star hopping can help. So what is star hopping? Star hopping is a technique that amateur astronomers often use to locate astronomical objects in the night sky. Now, like stepping stones across a river, astronomers navigate the inky blackness of space by hopping from one star to star until arriving at the object we were after. Star hopping makes it so much easier to find the objects you've never seen before by using the ones that you do recognize. So why not just use or buy a go-to mount? Well, yes, they are convenient, but computerized mounts don't provide as much of a challenge. A manual mount forces you to learn the night sky, which provides a sense of accomplishment when you find a target. Also, using a manual mount will sometimes result in finding interesting things along the way that you didn't even know existed. So you're on your way to a star or an object, and hey, what's that in the field of view? Now, star hopping with binoculars, having a wider field of view is the secret to success for star hopping. Binoculars have a nice wider field of view than a telescope, and there is no image inversion. So in other words, it's not flipped upside down or left to right, wrong. This makes it easier to see more of the sky and move in the right direction for each hop. Now, the thing to understand about binoculars, though, is that they require a steady hand. It's best if you can place them on a sturdy mount or a tripod, or sit in a chair, hold the binoculars by the large end, and bend your elbows so that they rest against your chest. That will help to stabilize them. Now, when you're ready to move to a telescope for star hopping, the finder scope is your key piece of equipment. The finder scope has much larger field of view than your telescope. Now, shown here are a few illuminated ones, which are the best suited for when the sky is really dark. One of the most popular illuminated finders is the Telrad. The image on the right gets projected onto a glass on the left, that little piece of glass there. So then the three projected circles are half of a degree, 2 degrees, and 4 degrees of sky. So what are we talking about when we're measuring degrees of sky? Well, there are 360 degrees in the circle. Any point directly overhead from you is 90 degrees from the horizon. Now, smaller angles are a little trickier, but your hands and fingers are a remarkably accurate and convenient measuring tool. When you hold your hand at arm's length, you can estimate the angles like this. So stretch your thumb and little finger from as far apart as you can. That span, tip to tip, is about 25 degrees. Do the same thing with your index finger and your little finger, and that span is about 15 degrees. Clench your fist at the end of your arm and hold it out with the back of your hand facing you, and that width is about 10 degrees. Hold about 3 middle fingers together, they span about 5 degrees of sky. And the width of your little finger at arm's length is between 1 to 1.5 degrees. Now, for reference, the moon is about 1/2 degree wide in the sky. Now, here's another example from the first star in the handle of the Big Dipper. We all know what the Big Dipper, quote, Big Dipper is, of course, Ursa Major, but to the last star in the bowl is actually 25 degrees. 15 degrees is the distance from the third star in the handle to the start of the bowl. 10 degrees is the width of the bowl itself. And 5 degrees is the distance between the last two stars on the bowl. And it's almost 30 degrees from the last star of the bowl all the way up to Polaris, which is our North Star. Now let's go even smaller. Now when you look through a telescope, you see the field of view of 1 degree or less, a very small slice of sky. Astronomers measure angles smaller than 1 degree in arc minutes, we call them, or minutes of an arc. There are 60 arc minutes in 1 degree, so 1 arc minute is 1/60th of a degree. The symbol for arc minutes is a single apostrophe like that. So if the full moon, for example, is about 31 arc minutes across, which is about half of a degree, coincidentally, so is the sun. This is why the moon covers the sun almost perfectly during a solar eclipse. And here's another interesting test you can perform the next time you're under the sky. Verify your latitude. Face north, in particular Polaris, while having a good view of the horizon, and see how close you can get to your actual latitude by measuring the distance from the horizon to Polaris using the methods that we described earlier. That'll tell you your latitude in degrees. Now, constellations in our night sky can serve as signposts to find our way around, showing the way to other constellations and objects. Now, one of the best is the Big Dipper in Ursa Major. So we start by drawing an imaginary line through the last two stars in the bowl, and that will lead us to Polaris, our North Star, which is right here. I continue on to the Great Square of Pegasus, a great square in the constellation of Pegasus. Another imaginary line drawn from the second star in the handle, intersecting through Polaris, will lead you to Cassiopeia, right this way. And then on to the Andromeda Galaxy. That's in the right spot. Next, drawing an imaginary line through the top two stars of the pot will lead you to Capella, right through this way, in Auriga, and that's a twinkling star in Auriga. In the opposite direction, take 3 stars in the handle and draw an arc down to Arcturus, and then we spike down to Spica in Virgo. Drawing an imaginary line through the right diagonally through 2 of the pot stars, ends up at Castor and Pollux, which are the Gemini, the twins. And that same diagonal line in the opposite direction will lead you to Hercules, the constellation of Hercules. Finally, an imaginary line drawn upwards through the 2 stars will lead you, in the pot, closest to the handle, will lead you directly to Deneb, which is our star in Cygnus, and one of the stars of the Summer Triangle. Now draw the same line with an arc to the left, and you'll end up at the bright star Vega, which is in Lyra. And then an imaginary line straight down through the 2 same stars in the pot leads you to the star Regulus in Leo. So we found a lot of constellations and a lot of objects just using the Big Dipper as our signpost. Now, in the wintertime, of course, we've got Orion as our signpost. In these next 2 examples, we use the 3 stars that make up his belt, Alnitak, Alnilam, and Mentaka, as guideposts. Now, if we draw a line through those stars and head down to the lower left, we arrive at Sirius, which is the brightest star in our night sky and the lead star in the constellation of Canis Major. Go the other direction, we draw an imaginary line through the same stars up and to the right, and we end up at giant Aldebaran in Taurus. And we continue on to the beautiful open star cluster of Pleiades, and both of these objects are in the constellation of Taurus. Then next up, we draw an imaginary line through the left foot of Orion, or the blue-white super giant star Rigel, and then up on through Mentaka until we get out to Castor and Pollux in Gemini. Castor is a sextuplet system. Finally, we draw an imaginary line through Orion's left shoulder, and the star Bellatrix, continue through his right shoulder, Betelgeuse, and on to Procyon in Canis Minor. And the final line starts at Orion's right knee, the star Saiph, up through Alnitak, and then on to the bright star and usually twinkling star Capella in Auriga. And of course, we have the winter circle. This is another big asterism that we talk about in the winter time. Winter circle, the hexagon, maybe today we call it the winter football. But it encompasses a large piece of sky, and many of the constellations are within that circle. So we can catch that anytime now. Right about 8 p.m. is about the best time. So that's my talk about those objects. I just wanted to bring up quickly a quick look at Stellarium. So here's Stellarium. Oh, am I sharing that? You guys seeing that?
Nope, see us.
No, just us. There it
There
is.
it is.
You got it now? Okay.
Yeah.
Okay, so let me, I wasn't even sharing my screen, guys. Sorry about that. Let me go back to sharing my screen.
It looks like you are.
Yeah.
I was sharing it out on the network, but I wasn't sharing it to you guys, I guess. A second here. Where'd it go? Hide. There it comes. Okay. All right, so this is our night sky tonight at about 8 p.m. This is looking north, but we're looking south when we're looking at most of our sky. There's Betelgeuse up nice and high. So this is the winter circle that we see around the side here. We can also, if we just quickly look at Stellarium, you can add through the configuration window here, you can add things called asterisms. So let's bring on the artwork first. There's our artwork showing us what we're looking at. And there is asterism lines. This can kind of get confusing after a bit because there's so many asterisms that are in the sky. Now, asterisms aren't constellations. Those are part of constellations, like the Big Dipper is part of Ursa Major, the W of Cassiopeia, the Great Square in Pegasus, and there's actually names of them all here too. So what I would recommend is that if you're looking at going out in the night sky and trying to find things, plan ahead. Take a look at this program called Stellarium. It's free to download from stellarium.org. Turn on your asterisms, and you can actually measure the distances as well, because down here as well there's a little ruler, an angle measure, and we can turn that on if we turn off these asterisms for a second, and we can say how far is it from the moon to Procyon right now, and it's 18 degrees. So we know the measurements that we use there to measure the night sky between the moon and the star Procyon would be less than the distance between your index finger and your middle finger, so, or your end finger. So you can use that as well to draw distances and give you an idea about how far away things are from each other. That's about it. That's a quick talk on star hopping. There's a lot more to cover, but we were limited for time, so we're just going to get into that much of the talk for tonight. You can always play this back later on. The show is up, advertised, and we're up on YouTube and Facebook later, so you can always come back and take a look at that part. All right.
All right.
Sounds like a plan, man.
Yeah, okay.
It was funny. I went out the other night when we had 5 minutes of clear sky. And it was nice to look up, and Orion was almost due south. And of course, you looked at Taurus and Pleiades, and the moon was there, Gemini was there, Leo was rearing its head. It was really nice to see, just go out and look without binoculars, telescope, or anything, just naked eye. And
yeah.
We don't see the sky that much this year.
Yeah, I'm just happy to look at the moon. Even if it's a full moon, I don't care anymore. Clear sky.
Yeah, it's just nice to be outside at night.
Maybe what we'll do in a couple of weeks' time is maybe talk a little bit about asterisms themselves, like the sickle of Leo and the Big Dipper, and talk a little bit about how to star hop, using those as ideas. So, okay, all right, Paulie, you're up next.
All right, all right. Let me just figure out how I'm going to approach this. I don't have a slideshow as such. It's frustrating. I don't have a slideshow as such. I've actually got my equipment hooked up in the observatory because what I just want to talk about briefly is people think, well, I'm going to get into astroimaging or astrophotography. I want to go out and buy a telescope, and that's about as far as I think. And I did it myself, and there's the only reason I'm saying that. And so what's the first thing you buy is the telescope. That's you think, okay, I've got to get a telescope to be able to go out and take pictures of the night sky. And I remember, and very briefly, I called a telescope dealer in Canada here, KW Telescope, actually. For my very first time I was buying something after I bought my little telescope from Mike. And I called up and I was talking with him, and I said, look, I want to take pictures of the night sky, and I want the biggest telescope you have because I want to get the best pictures. that was what I had in my head, right? And then his question to me was, well, what are you going to mount this on? And I just said, mount. So once we started talking and we started to realize that, the most important thing to get is the mount first and then telescope later. I didn't know that. And like everybody else, you think you get the telescope first and just put it on something, as long as it holds it up, it'll do what it needs to do. And that's not the case at all. So what I want to point out tonight basically is I'm going to show you my rig. It's just a picture, and I'll just walk through it very, very quickly. And then I'm going to show you what you need in terms just to be able to get it running and locked onto a target before you even collect a picture. And just so that to show people that it's not difficult to learn, but there's a lot of little things you have to learn. There's a lot of things that you need to do before you even start taking a picture, and it's called acquisition. And acquisition is really learning your equipment. And like Chris was saying about star hopping, know where things are in the sky and all that wonderful stuff. So I'm going to share my screen. And I'm going to do this one. It'll probably go into the abyss here. Let me just see if I can push this out first. And I'm going to share this one here. And it shouldn't go into the abyss now. There we go. Okay. And before I even show you that stuff, I want to show you this. So here's basically my rig that's out in the observatory. Forget about this one on this side. It's this one here. And the reason I want to show you this one, I just want to show you the components that you need before you can take a picture. So the first thing is that white thing that you see on the side, or part of it, that's the mount. That's the part that's holding everything up in the sky. And you need software to control that. You need software to tell it where to point. You need software to tell it to stay locked in this very position. You need software to tell it that when it hits the meridian, you're going to have to flip this thing over to the other side, called a meridian flip. So you need software to do that. That's just to run the telescope or the mount itself. Then you need software to run your camera. You need to tell the camera how cold it needs to be and how long you want to expose for. Basically that kind of stuff, the gain and all that sort of stuff. Because unlike a DSLR, it doesn't have built-in buttons. This one has to be run by a computer. Then you have a filter wheel, and you have to run software to tell it what filter do I want to use. And on top of that, up here, this rig that's red with this big box off the side, that's my electronic focuser. You have to have software to tell it how to focus, because every time you change a filter, you have to refocus. And then when you're setting up for the night, it has to focus. And then there's software in there that will actually focus it for you every hour if you wanted to. And that way there, as the temperatures change, it knows when to focus. And then on top of all of that, up in the very top, right up here, which you can't see in the picture, maybe I can in a sec. Yeah, right up here, there's another little camera and yet another little tiny telescope. And that's your guide your guide camera and guide scope. And you have to have software for it to lock onto a star. And then every time your telescope decides it wants to move somewhere funky, this thing's locked onto the star and it sends a pulse back down to the mount saying, whoa, Nelly, not yet. So it keeps it locked on the star so you don't get all these long, twisty, funny looking stars. And then that blue box that you see right there is the control box. And that controls on one side all of the data. In other words, you have to run a USB cable from the camera and one from the filter wheel, one from your focuser, one from the mount, one from the guide camera. So that all goes into a central hub. And then you have to power all these things. And again, that's on the other side of this blue box. That's what you do that with. So this has to have software to run, because this also controls my dew heaters, and it also measures the temperature and the humidity out there, and it knows when and how much power to give to the dew heaters to keep my optics nice and clean so they don't fog up or frost up at any given time. So anyway, so you need software for all of those things. So I'm going to show you the software that I use. So to start it off, when I first start up my rig, I'm just going to turn this down for a minute. down here, I turn on that blue box that has all the power in it that we talked about. So right here is called Pegasus Astro Ultimate Power Box version 2. So this is my software that controls that power box. Down here controls the heaters. Here controls all my USB data. I can run my focuser from it here if I want to. This gives me my power graphs, how much energy I happen to be using, and so on and so forth. It's an amazing piece of equipment, and it's designed to run in remote observatories, so you can do everything from inside the house. So that's the first thing that I turn on, and when I turn that on, that turns power on to my cameras, to my mount, everything that we looked at in that picture. Once I've got that up and running, the next thing I turn on is my PhD2. This is my guiding software. So the little tiny camera, the little telescope that rode on top to keep everything locked onto a star, this is the software that I need for that. And what it does basically, I'll just turn this off. Let's turn this off first for a second. Turn this up. So when I connect this up, I just simply go to this button here, which if this was turned off, would say connect all. I press the button. And what the guide camera does is it runs software to run the camera itself, so it knows what stars to stay locked on and guiding, all of the stuff that guiding software does. And there's another one that actually runs the mount. And the reason that it's connected to the mount is because your guide software also controls what they call dithering, which is just between each picture, it moves the camera a little bit by just a few pixels every time you take a picture. So at the end, when it stacks it up, it just helps reduce noise. So it does all that kind of stuff too. It also dictates when we're going to do our flip, our meridian flip, and I'll explain that in just a second. And so down here, of course, is all the parameters that you would adjust. And up here would be the camera. You're only seeing the inside of my observatory. The reason you're not seeing any stars, because there is no stars to show you anyway. But if I was running this, I would just turn on my camera here, just start, close this first, and then start looping. And then now it's actually looping. You can see it move a little bit, but it really, you're not seeing anything but the wall in the observatory. So this is the guide software. Now, the mount and the guide software have to work with EQ mod. This is sort of the heart of everything that connects all the drivers and all that stuff. It goes through a thing called ASCOM. And EQ mod is really designed to remotely run your mount. So when I show you all of this, it looks like there's a lot of stuff going on, and there is. But once you set it up, you really don't need to get into these parameters at all. But these parameters allow me to set my mount limits. It allows me to set my meridian flip. I have to put in all my coordinates. If I want to run at different pulse guide setting rates, all that stuff, that's all done here. Also on this side down here, this is where I do my parks, like my flats park. Anytime I move the scope and park it back, I can either park it in a flat park because I have a light on my wall that the telescope points. I can take flat frames, or I can just do a home park. If I do this, for example, I can park at the home. I can put it wherever I want to. But right now I'm in the flats park position. So anyway, so that's what this part of this software does. This part of the software over here is the part that you would use all the time. And this one allows you to control your telescope if you need to, the rate that you want to run your telescope, and the tracking rate. So if I'm doing deep sky, I'm going to be tracking in sidereal. If I'm doing lunar, I'll be tracking the moon. If I'm doing solar, I'll be tracking the sun. So this allows me to do all that stuff. So that's basically what this is. This is the EQ mod. So that's that software. So let's put him aside for a minute. The other software I run, which is my planetary software, which is Carte de Ciel, or Sky Chart in English. And this is where what I use to point my telescope. Some people use Stellarium hooked up to the telescope. Mike and I both use this. Our friend Emil in Moncton uses this. A lot of astrophotographers use this software. The reason I chose it and I was recommended to was because I was using Stellarium to run my telescope, but Stellarium is not as reliable as what this is. This has never, ever failed me. If it has failed, it's my error, not the software. This stuff works beautiful. So if I want to move my telescope, for example, and I'm going to show you something here, or I'm going to try to. Let's see. blue sky. Did I lose that? Yeah, where I'm using this, I might not be able to show you that. Just one sec. Oops. I'm just going to shrink this down for a minute. And there's something here that's blocking it. That's why. All right, there it is. I'm going to put this over here. So this is, I'm assuming you can still see this on the screen. Can you see my telescope?
Yep.
Okay, so that's basically the scope inside the observatory. And let me get back to this. And I'm going to see if I can superimpose. No, I can't. I can't show you that at the same time. But if I move the telescope, let's say I want to move it to the moon, then I'm just going to go and I'm going to press on the moon. And then I'm going to hit this and slew. But something's going to happen. You watch. It says the ASCOM driver reported an error. Of course it did. You know why? Because I'm still parked. So I have to unpark my telescope first. Oops. Speed it up so I can get over there quickly. Unpark my scope. And now I'm going to slew to the target. When I slew to that target, you're going to see this circle moving, right? That's telling me that the scope is moving. If I look over here, and you can watch my telescope actually slew to the target. So this is just an infrared camera I have in there just to make sure that there's no cable snags or anything like that. And it's just a good idea to be able to look at your telescope every once in a while, just to make sure that there's no bird sitting on it or a mouse on top of it eating something or dropping some nutshells into your telescope glass or something like that. And so that's right now it's going to be pointing to the moon. It'll stop here in a second once it finds the moon. So now I'm confident that it found the moon. I'm going to go back to here, and now we are in fact on the moon. So basically, so that's that software that I have to use. And then once it's there, then let's say if I'm going to image the moon for the night, actually it will be a deep sky target, but for want for better words, let's just shrink that down. And now I'm going to show you the acquisition software. This is a software that you use when you want to capture your targets. And it's really, really cool stuff. And this software is called Sequence Generator Pro. Some people use astrophotography tool. Some people are now using Nina. But I'm still using this for the time being because I'm so used to it, it works well. And what this does, this section up here allows you to hook up all your gear. So the camera, your filter wheel, your focuser, your telescope, your plate solver, and your auto guider. These are all things that need to be controlled by this software to be able to acquire the data properly. So to set up a target, really, really simple. Once you get used to it, you turn on all of your devices. When these are all orange and lit up, everything's running. Over here, I can keep an eye on my focuser position. I can keep an eye on the temperature of the camera, if it's cooled, the temperature outside, all of that stuff. If I want to do, let's say if I want to record Orion, I go to my tools, I go to Framing and Mosaic Wizard, and then I simply type in M42, which is the Orion Nebula. Whoops, M42. And before I do that, I want to show you this section here. I have to put in my imaging scale and my pixels and all that stuff. Basically, it's looking for the pixel size on my camera and the focal length, and it will give me an imaging scale. It has to know that scale to give you the proper view of what you're actually going to see when you actually take a picture. Because if you don't do this, it won't find the target for you properly, and you'll never find anything in it. So all you do is put in M42 and hit fetch. It's going to fetch M42 for me. I'm going to move this out of the way, and there it is. I simply click on it, and now you see 4 squares. That would be great if I'm doing a mosaic. I am not. I just want to take one image. So I just tell it I want one image, and that one red square that you see is the actual field of view of my sensor through my telescope that I'm currently using, and that's why I had to put all this information here. So I have this correct. Then if I want to just rotate that image and see if that's going to fit in my frame, which it does just beautifully, and it's wherever I lay that little screen, it's going to lock onto M42, and that's exactly my field of view if I had a rotator. If not, I go out and rotate it myself after I do a test image. But I know it's going to fit in the field of view. If I'm okay with that, I just simply hit create the sequence, and I'm just going to, I don't have a rotator, so I'm going to turn that off. And I'm going to say, okay, I want that sequence. I hit okay, yes, and created the image successfully. And there, now it's given me M42 right there. So now all I have to do is basically start lighting, putting in what I want to do. in my lights. Do I want to do dark frames, flat frames, biases, whatever I want to do? Kind of filter I'm going to use, whether it's red, green, blue, sulfur 2, hydrogen, oxygen. This is what's going to basically be dictating to my filter wheel what filter to choose, how long I want the exposure to be, and how many times I want it to expose. And then basically when it's done this run, it'll take on the next one and the next one and the next one. So you can load in as many runs as you want on this. So that's pretty much it. So once you've got all that done, you simply hit run sequence. I'm going to put no now because it's not going to find anything. And then it'll automatically go through. It'll automatically focus my my computer or telescope, and then it will plate solve. It'll find the target for me, put it exactly where I put that little red square on that image, and then it'll go ahead and set up my guider. It'll start. It'll calibrate my guider so I'm getting the best guiding I can. And once it's done that and it's all running, everything's tickety-boo, then it will start integrating, and that's it. All I have to do from that point is just watch. So that's pretty much it. That's what you have to do before you do anything on this stuff. So I'm going to stop sharing here.
Wow. And all I have to do is call Paul and say, "Have you got a picture for me? I can share." That's why I don't do this. It's just, you guys are
that's
just.
even before you take the picture, though.
Oh yeah, it's just that's crazy.
Yeah.
Like
And
that's why you guys
before
are
all
up
that, you
here
have
and I'm
to
down
know-
here.
Yeah, and before all that, you have to learn how to balance the scope. You know how to set up your optics. You know, there's a fair bit to it, and that's why I think Chris, you said just what that who was it you said Dalai Lama or somebody?
Oh yeah, Desmond Tutu. Yeah, I can
Okay,
eat
you-
an elephant one bite at a
How do
time.
you eat an elephant? One bite at a time, and that's the way astrophotography is.
Yeah.
One bite at a time. Get your mount, learn about it, learn how to use it. Get your telescope, learn about it, learn how to use it, and you'll go through that stuff.
Well,
and eventually you'll get all that to the point where I can take my rig outside, plug it in, and at least get it pointed to where I wanted to get it pointed to.
yeah.
And then just practice.
Yeah, and it's it's your passion now though, Paul, too. I mean you've dived right into this so hard now that to you it comes, and you've watched so many YouTube videos. I know you've told me that you've been on YouTube pretty well steady trying to learn about it, but your peak is just gone amazing. So anyway, that's why I enjoy sharing your photos. I'll do the other part. You guys do that. That's great. Perfect. All good. Do you want to mention your Sky News magazine?
Oh yeah.
Yes.
Thank you. On Tuesday night will be our 5th Subs and Stars thing. Now, the Subs and Stars is the program that I'm doing with Sky News magazine, and Alendra Bringes is my co-host. She's also the chief editor for Sky News magazine. And what we do is we use the robotic telescope. They collect all the data from the robotic telescope down in California, and then they send the data sets up to us, or up to Sky News, and then that's distributed out to people for free if they want to take on that data and try to learn how to use it. So this Tuesday night at 9 o'clock our time, I'll be doing the 5th in a series, and all these series are on YouTube. They're recorded and they're on YouTube should you want to go back and review them. And this one is going to be on what you see behind me, the Orion Nebula, and taking with their equipment. And this is as close as you'll ever get to the Orion Nebula. With the stuff that we use here, we don't get this detail in the Orion. Anyway, and this month's target is a big project in a way, because there are a lot of different data sets that are in here. There's 2 different luminance sets. There's 2 different red, green, and blue sets. There's a hydrogen alpha, there's an oxygen 3, and there's a whole lot of assembly to this particular target. And that's what I'm going to be going through on Tuesday night. And I may have time to actually finish processing the image. I may not, because just to get it assembled takes a fair bit of time. But if you can watch that video, you'll learn a lot about blending. And blending basically means taking 2 images and kind of putting one into the other, because the Orion Nebula is one of the hardest targets to actually do, people say it's a beginner's target, but realistically, it's beginners because it's one of the easiest things to see in the sky. You can take a picture of it with your DSLR, but most of the times we get blown out cores. It's always just blown out in the middle. So what this thing is here is it's to show you how to take the shorter subframes so you can get the core, those little stars you see right there, and then also the other frames to get all the stuff that's around it, and then be able to blend those two so that it's seamless, so that you don't see anything. It looks like one original picture. You have to do that with the color data. You also have to do that with the luminance data. So there's a fair bit of assembly to this one. So it might be an interesting one to watch because I'm going to be using PixInsight and also Photoshop. I'm going to be using both to be able to incorporate this project. So that's Tuesday night, 9 o'clock, Subs and Stars. And it's on YouTube and Facebook, so it'll be broadcast on both.
So it's called Subs and Stars. That's the page, right, Paul?
So then, if you go to YouTube channels to watch the other episodes, just type in subs, like sub sandwich, subs and stars.
Yeah.
And you'll find them there.
Awesome.
Yeah.
I don't know how you do it, but I'm glad you do.
It's the first time I've done anything like this too. So
Yeah.
this has been a learning experience for me, but I'm so glad that I did it. Now that when we do all the other things that we do, we're showing people stuff. There's some other tools now that I can show people how to do certain things if they get stuck. So I'm really glad that I did it.
Awesome. Okay. Too much gobbledygook there. Oh, way above my level. I'm going to go look at the moon for a few minutes, I think. All right. So now we're back to our other theory talk. We're going to run a little bit long here, folks. I did note that on both comments here. So we are where we are. Hopefully you'll stay. Anyway, we're going to go next to Bino Bud.
Bino Bud.
Let's go to Binocular of the week.
He should be butting himself onto the screen here any second.
He is.
There he is.
The fascinating part about this is you don't have to worry about cable management. You don't have to worry about software. All you have to worry about is picking up a pair of binoculars like Bino Bud does and go outside and look for the Christmas tree cluster.
Poor guy.
That's what our weather's been doing to Alrighty. The Christmas tree cluster was named for this triangular shape formed by a cluster of very young stars that look like a Christmas tree in visible light. The Christmas tree cluster and Cone Nebula are both discovered by William Herschel. He discovered the cluster in 1784 and the nebula in 1785. NGC 2264 is large, bright cluster, easily visible with binoculars. It consists of about 80 stars from 8th magnitude and spans half a degree. So, how do I find it in the night sky? If you went outside at 11 o'clock at night and oriented yourself 195 degrees south-southwest and looked up, you would see Orion and Betelgeuse, and you come across here to Monoceros, the top bright star, and I don't know, if you're sweeping the sky, you might see the Rosetta Nebula, but you come up from it, and it sits right in this area here. So come off Betelgeuse towards the next bright star to your left, and you should pick it up right in this, about 2/3 of the way across. Now, here it is again. There's Betelgeuse. There's that bright star. And there's the Rosetta. And straight up, and in this area is where you're going to find the Christmas tree cluster. Now, what will you see? You won't quite see this, but here you can make out the shape of like a Christmas tree, and then all the stars are the lights that are on the tree, or the balls hanging on the tree. What will you see in 10 by 50 binoculars? Well, this is what you will see. It might kind of look upside down, but it kind of looks like a tree there if you look down with the bright star at the top and then all the lights hanging off it. Compared to the full moon, it's a good size. It's probably 3 full moons in a full diameter. So it's a pretty easy target. It's quite bright. You might not pick off the nebulosity as well, but you will definitely pick out the stars in that cluster. There's no question about it. Now, how the Apollo astronauts walked on the moon, and how the millennial astronauts will walk on the moon. Get down, get down. And that's our Bino target of the week by Bino Bud.
Awesome. Another great one, Mike. I'm sure they're getting hard to find now. because you've picked up so many of them over the last 100 episodes or more.
I need 3 more to get 52. That's a year.
Oh, okay. Yeah, but you weren't doing them for a long time there, but glad we picked up on them. Awesome. Okay, we've got 2 more talks to go. We might not squeeze into what's up. We're going to go with Rosanna's talk. I think that's more important, so let's squeeze that one in.
Okay, just give me a second here. I've got to get it up and running here.
Okay.
So bear with me.
Bear with me just for a sec, because you might hear a sound here. I'm going to try to find the link to that. So just bear with me. I'm going to click on one of the YouTube videos, but hopefully it won't start playing. There, it might be right there.
Go to Shopify.com.
Okay, it did.
Hark.
I think this is yeah, go ahead. Anyway, it's subs and stars. It is listed under subs and stars. Lesson 1, lesson 2, lesson 3. So right on YouTube.
Yeah, there's 4 lessons right now. This will be the 5th one.
Yeah, okay. Sky News Magazine is how it's under. So.
Yes.
Okay.
All right. So I'm going to try to figure out where our meeting is. There we are. Good. Okay, I think I'm ready. Let me get the music ready and all that sort of stuff. We'll start sharing first.
All set?
And I am all set. This is this week.
Rosanna's Fun Fact.
Yay! Welcome back again, Rosanna. So glad to see your face. We have so many people that would love to have Rosanna on the show, and I'm not sure if I could wrestle her to do that or not. I would really, really love her to come on and say hello. And because I would really like the people to see who she is, and if you ever have a chance to meet her at one of the star parties that she's at, say hello. She's a fantastic person, and it's been such a pleasure working with all of her fun facts for all this time. So thank you so much for your contributions, Rosanna.
Absolutely.
Oh yeah.
Okay, so this week's fun fact says, "Hi, Paul. There are days when almost anyone might fall prey to feeling like they are just spinning their wheels, especially if one is in isolation or lockdown. Now, it is a perfect idiom for summer and the frustration of not being able to accomplish much." Now, let me just show some of the pictures here. So literally, all of us probably at one time or another have actually read or really been stuck in the mud, snow, or on ice, spinning our vehicle's wheels. And of course, spinning wheels could mean much, much more to a hamster. So if it works, this changes everything. We could go up to the casino. I love these cartoons. And in the mention of spinning wheels, maybe you remember the Blood, Sweat, and Tears song with that line. What goes up must come. Yeah, anyway, you know the song. You probably know where I'm going with this. So a SpaceX rocket launched in February 2015 in Florida is out of control. The booster was originally launched in February 2015 as part of an interplanetary mission to send a space weather satellite on a 1,000,000-mile journey. But after completing a long burn of its engines and sending the NOAA's Deep Space Climate Observatory on its way to the Lagrange point, a gravity-neutral position 4 times farther than the moon and in direct line with the sun, the rocket's second stage became derelict. Now, a Lagrange point is the point in space where an object tends to stay put due to the gravitational pull of 2 large masses, which equals the centripetal force required for a small object to move with them. These points in space have been used by spacecraft to reduce fuel consumption needed to remain in position. The second rocket was high enough that it didn't have enough fuel to return to Earth's atmosphere, but it also didn't have enough energy to escape the gravity of the Earth-Moon system. It entered into a rather chaotic orbit. Now, Falcon 9's upper stage is about 4 metric tons of space junk, and is now, of course, on course to hit the moon in a matter of weeks. Its velocity is about 2.58 kilometers a second, which is approximately 5,771 miles an hour, or 9,228 kilometers an hour for those who find bigger numbers more exciting. Now, Bill Gray writes software that tracks near Earth objects, asteroids, minor planets, and comets. He says the Falcon 9 will very likely hit the far side of the moon near the equator on March the 4th, 2022, just over a couple of weeks from now. The exact spot the rocket will hit remains unclear due to the unpredictable effect of sunlight pushing on the rocket and ambiguity in measuring rotation periods, which may slightly alter its orbit. Some say this is no big deal due to the moon's bulk and the likelihood of it happening a few days after the new moon phase. The crash will probably be unobservable, but there are others who say a lot can be learned from the first ever unintentional smack into the moon's surface, even if we don't go to watch it as it happens. As one scientist puts it, we already know what happens when the junk hits the Earth, but the moon crash could allow for observation or subsurface material ejected by the rocket's stride. Unlike the mom in A Christmas Story, whose words were, Ralphie, well, you'll put your eye out, came close to the truth. And I think the moon will be able to withstand a poke from a falcon. Oh my gosh, that is unbelievable. And that is this week's, whoops, wrong button.
Rosetta's Fun Fact.
Hey!
That is so cool.
Rosanna.
Why couldn't it hit like where we could see it?
Yeah.
All things, right?
I wonder
What a
how,
photograph that would be.
wouldn't it? I wonder how close they are to the fact of saying that is going to hit the dark side or the far side or whatever.
What's that?
I say they are saying it's going to hit the far side, I guess.
Oh,
eh? Yeah.
Yeah, yeah.
I hope it doesn't hit the
The
Japanese
Chinese
rover
lander.
or whatever.
Chinese lander.
World War III will start.
Oh,
right?
yeah. What's that?
You hit our rover on purpose.
It's bad enough we're wrecking our own planet. Let's wreck another one.
Yeah,
Yeah,
I know.
With satellite.
Oh man.
Yeah.
Let's trash it up a little bit.
Anyway.
Thank you, Rosanna, for that. Another interesting fun fact. Always
Yeah.
timely and always great. I'll keep an eye out to see what's happening with that one. That'd be interesting to see what does happen.
Next week, by the way, she's got a really cool thing on the James Webb. So
Oh, awesome. Okay, great.
stay tuned for that.
I'd like to keep touching that too.
Yep.
Okay, I got, what time have we got here anyway? We're at 9:03. Well, I could do a real quick 5-minute what's up, I guess, if that's okay with everybody.
What's up?
What's up? That'd be, yeah, Super Bowl night. What's up? Okay, let's go real quick with this one then, from the
We can
beginning.
do the halftime show.
We could, yeah. Hang on, first of all, I got to share my screen so these guys can see what I'm doing.
Well, you don't have a costume malfunction.
Yeah, yep. Probably won't happen again.
No.
That's super glue.
Yeah. Okay, quick look at what's coming up in the week this week. Oh, hello.
Look good.
Still good? Okay. I clicked the button. I thought it was a show. Uh-oh. Okay, we're up. All right. Tonight, the moon visits Gemini. Waxing gibbous moon visits Pollux in Gemini tonight. Castor and Pollux are the heads of Gemini, the twins. Pollux is the 18th brightest star in our night sky, 34 light years away, and is 9 times the diameter of our own sun. Not a little guy by any means, but that'd be a nice photo right there. Of course, you could probably get to both of them, actually, because the moon's so bright, but you still get that bright star Pollux, I think, in there. Okay, Monday night, tomorrow night, the moon passes the Beehive Cluster. On Monday evening, look for a waxing gibbous moon as it passes about 3 degrees to the north of the beautiful Beehive Cluster. How big is 3 degrees? 3 fingers. Or Messier 44 in Cancer. Although the moon and the beehive will both fit in the field of view of binoculars, since the moon is so bright, try looking at the Beehive Cluster by itself. without the bright moon beside it. So here's the Beehive right over here. That's a nice little open cluster, very popular one for sure. Conjunction of Venus and Mars, the February 13th, 14th, 15th, and 16th. Look at that. Check out the early morning sky over the next number of days. Brilliant Venus and reddish Mars will fit together in the same field of view of binoculars. So they'll be this way tomorrow, and then they move this way, both of them, but they're still going to stay in the same field of view for the next 4 days. Venus, Mars, and Mercury, the celestial trio continues. Our morning show continues all week with a wonderful celestial trio lineup of brilliant Venus, little Mercury, and the red planet Mars. Mercury will be replaced by Saturn near the horizon by the end of the month. So Mercury's dropping now, and Saturn will be popping up. And we'll have Jupiter in there too later on. 5 planets in our morning sky. Wednesday, the 16th, full snow moon. Her full snow moon begins to rise in the east-northeast on Wednesday evening at 5:48 p.m. Atlantic time. This is not a supermoon, as the moon will be more than 393,000 kilometers away, with the average distance to the moon being about 384,400 kilometers. So the moon may still appear large when it's close to the horizon due to the phenomenon we know as the moon illusion. Also on Wednesday, Mercury's at its greatest western elongation. So on Wednesday morning, Mercury will reach its greatest western elongation. That means the furthest west that it can reach in our morning sky. Mercury takes only 88 days to orbit the Sun, so elongations come around pretty quick. We'll have Mercury available for viewing for the next couple of weeks, and Mercury's at what we call superior conjunction, or on the other side of the Sun, again on April the 2nd. So get a chance to see it. Get Mercury now while you still have a chance to see it. Next 2 weeks, this is the zodiacal light. Here we go. This is a hazy glow that is going up through the bright planet Venus and going towards the Milky Way. It appears in the path of the Sun and the Moon, and the best time to see it is in the autumn during the hour before dawn, or springtime up to an hour after end of dusk. So we're calling it spring now. Also best in the moonless and dark sky location away from light pollution. So after Wednesday, we're past the full moon phase, so then we get into our waning gibbous moon, which means the moon is up later each night, and we'll get into our new moon phase. So good time to get out and check out the zodiacal light. This photo was taken by Sophie Melanson. Her photo and description. That was down at Century Farm Campground in St. Martin's.
Wow.
She takes some amazing photos. Of course, that's about it. But you can go to sjastronomy.ca. There's our February-March calendar. If you just go to the right-hand side of the page, you'll see this calendar there. Click on it, download it, and it'll bring you up everything that's happening over the next month and a half, which we have a lot of activities coming up, a lot of Saturn, Moon, Mercury conjunctions coming up, like really nice ones, Moon below Mars. So we've got a lot to look at over the next little while. And as always, take a look at Lisa's Lookup. She's at Ruby Moonbeams on Instagram, Twitter, and Facebook. Lisa's almost at 1,000 followers now. Congratulations, Lisa.
Wow, that's
Yay. So be sure to share her page out there. She offers an awful pile of great astronomy information. So good stuff, Lisa. Keep up the good work. Lisa's Lookup on Astronomy and More, it's called, on Facebook. And that is our talk on what's up. What's up? Here. Okay. Let's let's bring up some photos then, so we can close out our show. And I'll do another share. Okay. So let's get to my notes here. I can make sure I get everybody listed properly. And I just got to get to my folder. Okay, got some nice photos here to share tonight, as always, but here we go. Let's open up with this one.
There we go.
There we go. I got to bring this over to the other screen. Now, here is, Kathy Adams. She says, "Hi, Chris. This was the fastest shoot ever. saw the sun, had the scope out, set up, and I was able to get 2 shots before the clouds covered everything. Slight shadowing is due to the wispy clouds and some tree branches. Celestron 6SE, no reducer, ISO 100, 1/100th of a second. The sun is appearing higher in the sky, and I could actually feel the warmth from it. Oh, well, that's pretty good.
Oh, that's fantastic.
Yeah.
Nice shot.
Nice capture, Kathy. Great job. all kinds of sunspots there lately. Oh, it's just amazing. Kathy sends this one in as well. I found these on an old SD card that had gotten damaged and was able to pull a few images off. Good for you.
Oh, right on.
And with the constant clouds, it was nice to have some images of any kind. You're right. Jupiter, Saturn, and Orion's Nebula. So we're going to get into there's her Saturn view. Look at the moons.
Very nice.
She does great captures of those in the moons, yeah.
Yeah, she does.
And her Orion Nebula shot.
There you
Sweet.
go.
She's like, I really can't wait to be back outside again with clear skies. We all feel the same, Kathy. So
Oh, yeah.
believe us,
Absolutely.
yeah. What a dry month and a half this has been. Great job, Kathy. Thank you for those.
Fantastic.
We got this one from David Samard. David says, sun picture taken on the 9th of February with my Ioptron 60 millimeter solar. Here you go.
Yes, sir.
With my mini ZWO 120 millimeter. The picture was not processed. Still working on that. Can't find my head, he says.
Yeah,
It'll come around.
that was fun, so.
There, yeah.
Yeah.
And
Yeah.
moon today, too, at this is on the 11th, 2 days ago. Picture was taken with an Ioptron 60 millimeter with the next image 5. So they take a pretty good
Right on.
picture, those next
Yeah,
images.
they did a beautiful job.
Not bad.
For 60
Not bad.
millimeter.
Oh, you'd be surprised what you can get with those little things. Eh?
Yeah, I tell you.
Oh, yeah.
Yeah.
This picture, he says, was done with the next image 5 on an Ioptron mount and an Ioptron 60 millimeter refractor again. So there you go. Nice.
Sure.
Yeah.
Nice Orion.
M22.
Yeah. Beauty.
Target of the month.
Target of the month. That's it.
Target of the month.
Okay, we're going to move on to, thanks for those, David. Jamie, why not sent these in? Jamie says, hi, Chris. I took these photos on Friday night of the 80.8% waxing gibbous moon. It was clear early in the evening, but just as soon as I set up my telescope, of course, the clouds rolled in.
No.
Yeah, I don't believe it. Never happened to me. Yeah. Should bring up that footage sometime of Mount Carlton in the
Oh,
rain.
rain?
In the rain, remember that? Oh,
Yeah.
I got that somewhere. I'm gonna have to bring that up next week.
Oh, yeah, that would be
It was
fun.
just crazy. I stuck with it, she said, and just kept snapping photos as soon as I could see the moon on my phone. It was a guessing game of what I was actually capturing, but did manage a few good ones. You sure did. Look at that.
Well done.
There you go.
Yeah.
Awesome shot.
He does some great stuff. This is with her Dobsonian, isn't it?
Yeah, it is. Yeah, 8-inch Dobsonian and the phone. Yeah,
Fantastic.
Well done.
just great stuff. Nice Copernicus
Look at
there.
that.
Oh, look at
Bay
that.
of rainbows. There's Plato sitting down here. Nice stuff.
Yeah.
Okay, let's move on. Thank you, Jamie. Stefan Picard sent this in. He says, hi, Chris. Here's my latest version of the witch head I caught over the Christmas break. And, I mean, people are sending these pictures from Christmas. That's okay. We haven't had any clear sky anyway. But he's been working on. This is great about the cloudy skies. We get a chance to work on some stuff, right? I've learned so much from you, Paul and Mike. I think you've learned a lot more from Paul and Mike than me, but I appreciate that. And many others in our community about how to constantly improve. The measuring successes of this image are both, one, the isolation of the Witch Head Nebula to bring it out as a faint target, and two, also how I finally tamed Rigel's brightness, which, if you remember, was blown out in previous processing attempts. Still much to learn, but you're doing very well, Stefan. Great job.
You're coming a long way.
Yeah.
Okay, we're going to move into Bridget Green now. Bridget says, hi, Chris. I thought I would send a few photos. I like the effect of the moon between the branches in this photo taken back in the fall. I do, too. That's beautiful.
It's
Very
awesome.
nice.
Well
Love
done.
it.
Love the way that people frame their photos. And I grabbed the camera on the Friday for the day shot. And earlier this week, we had rare cloudless sky for a change for these shots of the waxing moon.
Very nice.
Well done.
Oh, demons.
I love daytime.
Yeah, daytime moon day. So I just use a Canon PowerShot SX50, but I am working at finding a DSLR to move up to soon. There you go.
Nice
Very
shot.
nice. Yep.
Thanks, Bridget. We have another one now from Denise Goche. Denise sent this one last week in Beldoon. She said there's bright Venus,
Venus.
the
Yeah.
morning sky. So that's
We see the clouds too.
that's just hammering out there now. It's just like it's at its brightest right now, but it's the third brightest object in the sky anyway, behind the sun and the moon. So there's no mistaking it for sure.
Yeah.
Thanks for that, Denise.
Nice shot.
I got these from Matthew Dupre. Matthew says the moon rising with some high-level clouds over the ice. That is
Oh,
beauty,
beautiful.
Oh, that's nice.
You'd almost think that was the sun, wouldn't you?
That looks
Yeah,
cool.
right,
too.
yeah.
It
Yeah.
really does. Especially with that orange glow.
Mm,
Yeah.
well done.
I think it'd wash out the stars though.
Yeah, sure. Yeah, sure would. Yeah, that's the difference for sure. And he said he got this one of the Whirlpool Galaxy, about 30 minutes
Oh,
total
wow.
exposure, and
Oh,
no
nice.
no calibration frame. So well done. I love that.
Very nice.
That's a beautiful
Oh,
galaxy.
yeah.
Oh,
That
even
never gets old, eh?
even through the eyepiece, you get to see that you get to see those bands, eh? Those
Yeah.
That's so cool.
Yeah,
awesome,
nice
very
work.
very nice. Okay, we're going to move into Lisa Fanning here now. Lisa has Moon and Lighthouse.
I
She's
love the way that she
Oh,
lined up.
Isn't that cool?
she framed that so well.
She did, yeah.
And what's cool is the moon is about the same size as the globe.
Oh,
on
yeah.
top of it.
Oh,
Yeah.
yeah,
Like
That's neat.
it couldn't have been more symmetrically set. It was beautiful.
yeah. She says, lighting the way. She got that in quotes. Having some fun with the moon at the end of a fun day. The Sandy Hook Lighthouse is the oldest lighthouse in America since the original
Wow.
Boston light was burned down during the American Revolution. Well, isn't that something? I enjoyed playing the game of place the moon in a fun position and was able to capture it atop the lighthouse. There's her other shot there.
That's still a nice
Using
shot too.
Yeah,
Amazing.
it's an
Yeah.
iPhone 13 taken on February 11th.
Very nice.
Thanks, Lisa.
Yep.
And we got this one too. She said, I just had to photograph the moon everywhere we went today. Beautiful in any light. She used a Canon PowerShot SX70HS.
Right on.
Nice
And
stuff.
I borrowed this one.
Different days throughout the day, eh?
Yeah, yeah, it's awesome. Rita says, I'm going to be joining you from down under. Rita, where are you going? Going down under.
And have a Vegemite sandwich.
There you go. Okay, so we're going to go from here to another shot from Lisa. Mission accomplished. She said the Hyades, the Bullhorns, and Taurus to the left, and the Moon and the Pleiades to the right.
In the middle. Yep.
Well done. Yeah, that was
You got it beautiful.
caught it really nicely. Yeah,
Very
that
nice.
was it. I wish we had clear. We didn't have we had cloudy sky that night again. So, of course, another event. Yeah. This one here again from Kathy Adams. She's, hi Chris, the fastest shot ever, but I beat the clouds by mere seconds. So, wow,
It's a race now.
a lot of detail there. Yeah, it is. Seem to get that a lot.
Really good, eh?
Yeah,
Really clean. Beautiful.
really
shot.
clean. Very nice. Yeah. Okay, we got this one. I borrowed this from Robert Gadet. Robert said the M45 Pleiades cluster, single exposure of 2 minutes, Canon T7i, 135mm lens at 135mm and f5.6. Tracking done using a Skywatcher Star Adventurer Pro 2i. I love that cluster. It's not there's
Yeah.
nothing
Well
as
done,
nice.
Robert.
Yeah.
In binoculars, it's
it's
kind of see.
Yeah.
I love the way that just stands out in that picture, though. That's cool.
Yeah, well, the
It's-
spikes really make it pop. Eh?
They do. Yeah. Great job, Robert. Thank you.
Yeah.
Very well done.
Now, last night we did get a couple of sunsets. This is my sunset shot from Milledgeville last night. I saw the sun at my window and I said, oh, I got about 5 minutes. Jumped in the car, ran down the road, stuck behind somebody, and then went out around them and zipped down the road, tried to set up my camera in time to offer it live, and didn't get there in time to offer it live. Anyway, you can see just the sun just kind of popping, just losing it there. But what a nice sky last night. It
Well,
was
look
just,
at the like just to be out in that
yeah.
and see that.
These are just
It was crazy
was it
sky.
my cell phone picture.
Yeah.
But then, yeah, that one there was another shot. So I put these up on the page, and then I get a lot of people started joining me. So this is what I love about the Facebook page. People are interacting so much with it. So Bob Ferguson sent this one in from Kennebecasis River in Rossay.
Right on.
Very nice.
Awesome. And then I got this one from Hudson Bass from Redhead,
Oh, that's cool.
along with this one.
Oh, pretty.
yeah. Just
Yeah.
peeking up, right? Beautiful.
Yeah.
And Danielle Zamerda sent this one in.
Oh, right on.
Looking at the street.
look at that, eh?
Yes, sir.
From Kathy Shaw.
Wow.
Yeah, just like they just kept coming.
Yeah, like wherever you were, it just lit up everything.
Just beautiful. And Pat Bacon sent this one in. Pat, nice shot.
Beautiful.
It was just the sky was on fire that night.
It was. It was just incredible.
Heather Sheehan sent this one in. What a great spot to be sitting and watch the sunset, huh?
Can you imagine? Eh?
Hey, the steaks on the Barbie, and away you go.
Oh,
Yes,
what a trip to be there every night to the
Yeah.
planet.
Tanya Dempsey sent this one in. Great shot, Tanya.
Wow. Look at the colors.
Beautiful, yeah.
And we got this one from Jess Levitt.
Yes,
Thank
sir.
you, Jess.
Look at that. Sky's on
Clouds,
fire.
clouds add so much to it. And Rael Guimond, my brother-in-law, sent this one in to me.
Right on.
Where's that, Chris?
That's out in Rosse.
Mhm.
Rosse,
Yeah.
yeah, just past
Where we had that star party.
the fishing shacks there.
Yeah.
Yeah, where we had, yeah, exactly. And Gail Taylor sent this one in. She said she missed the sun, but she caught the moon. So
There you go.
there we go.
Yes, sir.
Nice shot.
And if you have photos that you'd like to send in, please send them in to Sunday Night Astronomy Show, or send them into snas@astronomybythebay.ca or Sunday Night Astronomy Show at gmail.com. We love getting them, and we love sharing them.
Absolutely.
Yep.
Well done, everybody.
Well done, everybody. Yes, thank you.
Thank you.
Okay, I guess we're into 9:20. Here we are again.
Yeah, there you go.
Oh well, okay. All right, so I guess
That happens.
I got nothing to do. I got no life. So in closing then tonight, our special thanks again, once again, for your continued support out there. Special thanks to Rosanna again for another wonderful Fun Facts episode. I'll be watching for that rocket crash now. Yeah.
Yeah.
And remember, we do love getting your photos, so send them into Sunday Night Astronomy Show at gmail.com or snaz@astronomybythebay.ca, or just send them in my Facebook page, and we'll be happy to include them on our next broadcast. Also looking for suggestions for future topics. We did get a few this week, but please send them in if you have anything else we'd like us to present to you, because this show is for you. So give us some topics. We're tired of trying to think of them, so please come up with some ideas. So
Please.
if you have, please. And please let your family and friends know as well that we are here every Sunday night to try to edutain you a little bit on the night sky. So for now then, from Mike and Paul and I, stay safe, everybody out there. We wish you all clear skies, and we hope to see you again here next week at the same time. And remember, as we like to say, folks, keep your scopes pointed up.
Oh, yeah.
Have a great week, everyone. Good night. Good night, everybody.